Good morning, grade 7. In this video, we are going to check the exercises from the workbook. I'm going to start with Lesson 1, Earth's Motion. Your workbook, page 206, 207, and 208. This is Lesson 1 in Chapter 20. It's about Earth's motion. First of all, we have to organize information about the Sun. The answers to this exercise are found on page 727 in your book. So first, about the Sun. It's about 150 million kilometers away from Earth. Its energy comes from nuclear fusion. The core temperature is more than 15 million degrees. As for the surface temperature is 5,500 degrees. The Sun's energy reaches Earth as light and thermal energy or heat. The second exercise, we have to complete information about Earth's revolution around the Sun. The answers to this exercise are found on page 728. First, let's define revolution. Revolution is the motion of an object around another object. How long it takes Earth to make one revolution around the Sun? It's 365 days or 1 year. You can write 365 days, 0.25, it's also correct. Definition of an orbit. It's the path an object follows as it moves around another object. And what is the force that keeps Earth in its orbit around the Sun? It's the Sun's gravity. Now, in this exercise, we have to arrange facts about Earth's rotation. The answers to this exercise are found in your book, page 729. Earth's rotation. First, what is rotation? Rotation is a spinning motion. A rotation axis is the line an object spins around. One complete Earth rotation is called a day, and it takes 24 hours. Earth's rotation axis is always tilted in the same direction by the same amount. Earth's rotation makes objects in the sky appear to move across the sky, to rise and to set. Now, we have to analyze the interaction of sunlight with Earth's surface. The answers to this exercise are found on page 730. First, since the Earth has a curved surface, the energy in a beam of sunlight is spread out more at the poles than at the equator. This makes Earth colder at the poles and warmer at the equator. If you remember, we talked about that when we studied this lesson. The Earth is warmer at the equator because the surface on which the sunlight is hitting the Earth is way smaller than at the poles. Identify the direction of the north end of Earth's rotation axis for each of the 4 seasons. Put a check mark in the appropriate column. The answer to this question is found on page 731. So, the seasons, the axis is tilted toward the Sun during spring and summer, away from the Sun, winter and fall. Now we have to define solstice and equinox. The answers are found in the book, page 733. The solstice. It's the day on which Earth's rotation axis is leaning farthest toward or away from the Sun. And the equinox, it's the day on which Earth's rotation axis is leaning neither toward nor away from the Sun. Now, in this exercise, we have to identify which season is beginning in the northern hemisphere for each point in Earth's orbit. Then we have to indicate whether the amount of solar energy received by the northern hemisphere is increasing or decreasing throughout each season. The answers to this exercise are found on page 733 in your book. First, the December solstice. The season beginning in the northern hemisphere is winter, and the solar energy is increasing in the northern hemisphere. March equinox. The season beginning in the northern hemisphere is spring, and the energy is also increasing. Now, June solstice. The season beginning in the northern hemisphere is summer, but the energy is decreasing. And September equinox. The season beginning in the northern hemisphere is fall, and the energy is also decreasing. Now, we have to describe the height of the apparent path of the sun through the sky in the northern hemisphere at each solstice. The answers to this question are found page 733 in your book. For December solstice, the path of the sun is the lowest across the sky. As for June solstice, the path of the sun, the apparent path of the sun, is the highest across the sky. And now we have to suppose that Earth's axis were tilted 90 degrees instead of 23.5 degrees. What might the seasons be like? First of all, during our summer, the North Pole would point directly at the sun. 6 months later, the North Pole would point directly away from the sun. So seasons at the poles would alternate between being extremely hot and extremely cold. At solstice, people at the equator would see the sun circling near the horizon instead of rising and setting. It would be very cold at the equator during solstice. The seasons all over the earth would probably become much more extreme than they are today. Thank you very much.